Hey.
Okay, so we have to use the microphone so it gets the recording, but also that one.
Fine.
Okay. Well, we're going to get started since Courtney's here. We'll get started now. So, this is, I don't remember what do we call this? Oh, weaponizing AV. No, weaponizing AI for AV. Weaponizing, yes, one of those. I don't know. I always start with titles and work my way backwards. So you're seeing what the slides show up here. This is what we're going to do. We're going to talk about local AI and leveraging AI models for doing AV and IT calculations because that's cool and we're all nerds. Seriously. So if you recognize any of these words up here, good on you. If you don't, that's also okay. Let me give you a quick rundown of what we're going to do. A lot of this is going to be Mark and Justin kind of chattering back and forth in some sort of special nerd language because they get very excited about it. And they have spent the last 3 hours changing things in the presentation.
Actually, since January.
So,
We'll change before we're done.
and it'll change probably, yes, before we get to slides, they will update slides and we'll change them. So the concept here is we're going to talk kind of at a high level about how this works and how it's architected. And Justin is waving at, what?
We're out of chairs. I was telling him to bring a chair. Do we have an extra chair?
Yeah, what language does this mean, chair?
Chair. There's chairs right there.
Chair.
You got one, maybe?
We're going to show off kind of how this works and what it does. We're going to talk about how to build your own. We're going to talk about why you want to do this locally because AI, and even if those of you who have pro accounts on Gemini, Copilot, GPT, whatever, I'm trying to make that a thing. Everyone, Copilot, that's how we say it. Say it at work. People will think that's correct and start doing it too. It's weird. But if you have the pro accounts on those, yeah, and Cloudy as well, you will still run into limitations on how much of this you can do. It starts to charge you more, or they ask you, would you like to upgrade your account, sort of thing. A lot of those flat rate accounts are going to be going away, so they're going to kind of ding you per token. We'll talk about all this stuff. So there's advantages. I'm just reading stuff off his slides now. There's advantages to building these locally. And so that's why we're going to focus on building this local. There's obviously limitations because we still working on it. It's not done yet. We are constructing a 66,000 square meter data center right out back. It's not done. When it is, we'll use that. But for now, we're running it on a laptop, and you'll see why the performance is a little bit different. So, okay. Any questions before we get started on all this stuff? Oh, those of you who brought laptops, if you're taking notes, that's great. If you want to try to follow along in what we're doing, it's going to be a challenge just because a lot of these things, and Mark will demonstrate some of it, when everything is installed, dialed in, configured, and everything, it may take 2 or 3 minutes each step for it to do something. And then if you're going through an install process, it can take 20 or 30 minutes, sort of thing, best case scenario. We are going to give you copies of all these files. There's a QR code at the end. So take a screenshot of it, do whatever you want. You will get a copy of all of our code. You're going to get, Justin, what are we up to, 7,100 lines of code?
Yeah, I've created a markdown file, which you'll understand what that is.
It's a text file.
It's basically a text file of data.
Don't get fancy.
That is 7,000 lines long. That is every math equation that you could ever think of in the AV industry. And I use that in the frontier model to do my AV design work.
He's already using weird
and
stuff.
And we're gonna explain that difference of the local model. So again, if there's terminology that we're not explaining, which we're going to get to, please ask and
they are
raise
going
your
to use
hands.
words, and you're going to be like, "Am I supposed to know what that means?" Raise a hand and say, "What the hell does that mean?" Because these guys just make up stuff.
Please do.
But anyway, so yes, we will give you the code. We will give you all the files. We'll give you all the instructions to build this yourself. We'll talk you through that process. For those of you who want to hang out afterwards, we will be here. And if you want to actually try some of these installs and things, we're happy to kind of walk you through that. So, all right. Are you ready to set some expectations?
So yeah, let's set some expectations. Once we get into the lab part, we got to make sure laptops are charged. Now might be the time to kind of think about that if you're wanting to use that. Obviously, we're going to be concentrating on building a local LLM that runs locally on a computer. This stuff works. I've got 17 agents that run my business that do all kinds of POs and invoices and everything, and I barely touch my business now. So it's very useful.
Touch my business now?
I barely touch it. This is how it's going to flow. We're going to show you 3 examples of the local model actually working. Then we're going to get into the presentation. After the presentation, about 40 minutes or so, I'm guessing, we're going to go into lab mode, and that's where we're going to walk around and kind of help out and show you all how to do that on your local laptops if you want to. Another expectation, hardware matters. For example, before this presentation, Chris had a thumb drive, USB-C, supposed to be fast. I put it on my laptop. It was transferring at 300 to 400 meg max. Chris's laptop was 800 to 900 meg, so it went super fast. My transfers took 30 to 40 minutes. Mileage may vary on how this experience is going to work on each laptop. You might have to have administrator rights, things like that. So don't get frustrated during our lab time if something doesn't work. Think of it as a learning opportunity. Again, I've been doing this since January, working through this and learning. It's not perfect. You have to work out the kinks, but once you do, it eventually works. Again, we talked about this. These are very large files. The model, Quinn, is around 9 to 10 gigs. Olama, I think, is a couple, 3 megs or something like that. There's some other files in there. We're basically talking about a 16 to 19 gig project file that we're going to be dealing with. So if everybody's trying to download at the same time on the guest Wi-Fi, that's probably going to be a bad experience. You're walking away with real assets. We kind of addressed that with Chris. You're walking away with my file. The file that I created was about $50 in tokens. We're going to give that away for free. That's been developed, again, for the past month and a half. The trade-off for running local versus in the cloud, we're going to actually see that happen. I'm going to have what I call my Pocket Justin. I'm Justin. Pocket Justin's my little assistant. Running over here on the Frontier model. If you hear Frontier model, that's just cloud-based. That's all that means. Then we're going to show the same thing running locally over here. We're going to get the same output, but you're going to see the difference of how that local model works versus this one. I realize that this room can't see this TV, that room, so we might have to come up here and kind of look, and this is going to be after the presentation anyway. We kind of mentioned this already. You're probably going to hit an error if you try to do this in the lab. There's going to be some issues and some errors that pop up. A few of us can walk around and help with those and see how that progresses. Again, it's a learning opportunity. Let's see. Admin access, we hit that. Ask questions if you don't understand something, especially when Mark talks. Use a lot of big words.
What?
A lot of fancy words. I might have some questions, even what he's talking about. So please don't hesitate to ask if you don't know something. A lot of this terminology is brand new, and it's being made up daily, such as harness and things like that. What the hell is a harness, right? Any questions about how this is going to flow? Perfect. Okay. So Mark's going to go through some presentation stuff. He's going to drive. Mark and I are kind of going to go back and forth on this presentation. Once it's done, again, ask questions during the presentation. Once it's done, we're going to go into lab mode. Everybody good?
Is everybody scared?
Don't be scared.
Okay.
It's a little scary.
It's not that scary. We're going to show you first is the actual model and the agent running. This is what everybody will have when they're all said and done. This version of what's running. If you were here early, you heard us arguing over prompts. So we wanted to show you what these actually are going to do on my M5 MacBook Air with 32 gigs of RAM. Right? So this is 100% on here, local. This agent is built for 3 specific use cases, and I'll get into more why we simplified that down, but I'm going to give you one example of each of these use cases on this local model. So this first one, I believe, is display size. So we're going to go ahead and fire this up. What you're going to see is you're going to already start to feel that difference, right? This is not ChatGPT. This is not. Can I read this prompt? What size display do I need for a room that is 22 feet deep by 15 feet wide? Right. And so in the secret background of what's going on, I've set up the knowledge base in here very specifically for common room types within our learning spaces, conference rooms, and the like. So it's pulling, it's using these words, checking the knowledge base. Here's some guidelines it's going to run through, and it's going to start cranking out an answer. Right? It's going to say, okay, based on what you give me, here's where we go. It's going to do the furthest viewer. It's running it. But you're seeing all this. You're seeing the tokens per second that my machine is capable of doing right now. Right? So we can get into arguing about all the specific math for all the different variants of CTS that exist within this. Roughly, we're getting 98-inch display.
And we just tested that before, running on that 7,000 line markdown file. What he's referencing is 3 small markdown files. On the Frontier model, we got the same exact answer. So the result was the same, just a little bit slower because of the computer that Mark's using.
Are you talking trash with my MacBook, dude?
Yep.
I just got this. Raul said it was going to be fine, so I don't know what you're talking about. All right, so next example is speaker coverage.
Audio coverage uniformity standards.
Yep. And so how many speakers do I need for a room that's 35 feet deep, 60 feet wide? We've all determined this is 8.5 feet.
Roughly.
There was a lot of conversation. We had lasers, people with tape measures, and dental floss, and all kinds of stuff. 8.5 is what we're going with.
Roughly 8.5.
And so, word of caution, the data set on this is biamp here. There's no. We used biamp speakers and they fed this thing. They didn't even show up to the presentation. Okay, so we used biamp speakers as our
They're
baseline.
back there.
Are they? Oh, they are, right there. I thought the other guys were going to be
So
here,
what
too.
does Mark mean by we use biamp speakers? We actually took the specifications of each speaker, loaded into the markdown file, so the math uses that specification
Those
only.
Yes, you're right. Absolutely. 100%
Just to
right.
clarify.
Made it, simplifying it down. And when we get into the minutia of under the hood, the more we want to control the knowledge that the agent is using, the better off that response is going to be and more timely it's going to be. So you're already going to start to see that latency. For those who are used to having ChatGPT or Claude A or Copilot using it, you're going to see that running. And I have left this up in the background. I'll explain what's going on back there when we get to that portion of the show. And so it is now determining what and how many speakers it's going to give us. It is intentionally prompted to show us the math. I've set it up to make sure it's showing that every time. It's running through based on the DeSono speakers and what was the other one we did, Chris? The lay-in 2x2 grid. Yeah. Yep. And so, there we go. And when we get to the end, when we start comparing Pocket Justin, Cloud Justin to this, we'll start to see where they're overlapping and where it's not. So total speakers for this room, 8 is what it's recommending, based on this rough math we have. All right. And then we have Larry's favorite prompt, the conduit fill. We'll dump that in. And we're going to see if somebody can find the problem with this when it happens. I'm not seeding it, but you guys find the problem when it happens.
Who pulls HDMI through conduit still, right? Yeah,
Right.
that's
Dave got it.
fun.
Right. And so in the knowledge base, it knows the general reference of the cable size, not the head size. And I left it out specifically so that we can see that. If you wanted to build your knowledge base with that level of detail, you could provide that in there. But I left it because I'm lazy. This will work both ways. If you tell it cables, how many you have, it'll give you the conduit size. If you say, I have a conduit that is this big, how many of these cables can I put in it, it'll give you that as well. It works both ways. All right. There's a cloud. It's coming. It's burning. Here we go. Showing us the math. And right there, there's your issue. What HDMI cable is a 1/4 inch for the head size? We know that, right?
Only need a 3/4 conduit to do that. Yeah, right.
Okay. So those
So
are the
again,
basic examples we're going to show you guys.
Be careful when we start to construct, again, our markdown files of database and information. You have to make sure everything's correct and specified in a detail that you want to see on your output. If you accept that you understand that you know you can't pull an HDMI through a 3/4 and you can manipulate this after you get the result, then that's on you. You cater the output to what you want to see based upon the database that you create. Database is that text file or that markdown file that we load into the project.
Okay. So I wanted to show you so you can understand what that outcome would be. That's what we build towards if you have the files when you leave. That's what you're able to build with all the files and all the resources we've given you. So back to the presentation at hand. I guess we're going to go into prompts and definitions. Yeah, right here, right there. Okay. So covering quickly, Chris mentioned why local. How many people here actually have accounts? Pro accounts, max accounts, anything like that?
Few people, okay.
Okay. How long have you all had them, roughly? Just throw out a word, anything. 3 months? 6 months? Okay. You're all living in the tail end of the golden era of AI right now, okay? That subsidy is going to end. The capability you have for the price you're paying is going to go away, right? Every one of these companies are trying to go public. The real cost to do what you all have been doing in that frontier model, and we'll get to the definitions of that. So those accounts, recent audits were saying, if you're using those, that $20 account, people who are using those at the professional level are getting between $500 a week of actual value. That's raw GPU costs and power costs in the facilities. The pro accounts, people that are using the big $200 a month, those people are averaging $2,000 a week worth of GPU usage and electric. Okay.
So somebody's losing money somewhere.
Somebody's losing money on that. And pro tip, it's not going to be the cloud providers at the end of the day. They're subsidizing that to get everybody here to use these models, right? And so there are other ways you can benchmark those costs. If anybody has used anything on Amazon EC2 pricing, where you can go buy a cluster of GPU, getting RTX 6000, which is kind of the GPU from NVIDIA, those are upwards of $8 a minute to run. So the cost to do this level of compute is going to go through the roof. All right, and so that kind of brings us into, well, why is there value having this done on-prem? And I'm saying on-prem, on my stuff, in my stack, on my hardware, is because that cost to access those cloud models is going to go up tremendously. You're going to start seeing it. You're already seeing them starting to claw back some of those costs and raise prices. If you're a power user, you're probably seeing your limits get hit faster. You're starting to see a lot of that cap starting to set in.
There's also peak usage time, so if you're using it during the day, you're taxed more on that, and that's only going to exponentially increase. So if you're doing a lot of Claude code, if you know what that is, do it at like midnight. It's cheaper.
Last kind of point of this slide, doing local, for a lot of the calculations we're doing, we don't need to have a full data center to do these calculations. They are known. It's equations that can be run really quick. So do you need to call up a giant cloud model to do the math? You all probably can do it really quick screen sizing based on that. So we don't need to have an entire data warehouse to do that kind of work. So what can we do local? Think of small calculators that are small agents being able to do these types of jobs for you rapidly. All right, Chris, next slide. All right, basic tools definitions. We're going to try to go through these pretty quick. We're not going to get stuck in a lot of this. A lot of what we're going to talk about today, you probably all have heard prompts. We kind of know what prompts are. Basic instructions, either through your ChatGPT, those different tools, what it is you want it to do. What's the instructions, right? The models, think of those really, really roughly as the recipes. They're using your instructions. They're building those based on what you're saying.
It's kind of like the brain.
Big brain, right? Big brain. Agents running multiple of these requests and queries together. You can start to automate these things. You can set them, and they will start to work on behalf of you, right, Justin?
Agents use the brain to do work. I'm going to try to dumb this down to Kentucky level, right?
Kentucky level, all right. And tokens, the transaction piece. None of this works without tokens. Roughly 3 characters.
Tokens is money.
Right. Model reads, these letters equate to tokens. Tokens in, model, crank it through, tokens out. What you put in, what you put out, all cost tokens. Right? So that's the actual piece that's generating revenue for them. There is a lack of tokens in the economy right now. All tokens are actually spoken for. We don't have enough compute to actually meet all of that tokens.
So I don't know how much I call it my Atlas system that I built that runs my business. That Atlas is an orchestrator that runs 17 agents. I queried that before this presentation. It took me 5 million tokens to build all of that since like February. If you know a token calculator, I think that's a few $1,000s. And that's before the cost increase that we're about to experience, to kind of equate tokens. And so a $50 file, a few thousand tokens, I'm not sure.
Okay. Other side, we have these last 4. We're going to dive in deep on them. I'm going to mention them really quick here because these are your 4 main pillars of your local agent. It's going to be your gateway, That's how you're communicating with it, the device, the web page, how you are communicating with that. If you went to ChatGPT, that white background, the one you just saw here, that is your gateway. Your harness is what is going to actually wrap around that model, and then that's what's going to interface with your gateway. So think of it, it's the translator from the engine to the actual web page.
So harness is basically the front chat engine that you're typing into.
Yes.
That's what you see in ChatGPT. That's your harness.
No, the gateway is the HTML. They can collapse. Harness and gateway can be one piece of software. For this thing, I'm breaking it apart as two distinct pieces for you guys. Because it has some key distinction. We get into actually deploying, you're seeing where it goes. So gateway, how we interact with the human piece. Harness wraps around the next piece, which is the model. That's the brain. Right? There's lots of different models out there, all different sizes.
They do different things.
Yes.
Some are better at creating graphics. Some are better at engineering and math.
Yep. And so we're going to use a smaller model today on this. You can get really, really giant models that take up lots and lots of space. You use tons of GPU and CPU and resources and electric. We're not going to run those, but when you're doing the cloud version, you're running those massive giant models. The one we're going to run today is like 9 gigs total. And then our knowledge. Basically, the documents that our agent is going to reference to drive the output that we see. What's its intelligence? What are the files that we're giving it to base how that model is going to respond?
Those are those markdown files that I was talking about. And if you have a big markdown file, you can rag it, compress it, and then cut it back so your models aren't cranking through a bunch of data and gets results faster. Question?
Yep, RAG. Retrieval, augmented generation.
Retrieval augmented generation.
So-
That's right.
So the RAG, when you get into the real definition of where it goes, you have a lot of documents. RAG can be used to parse those documents to put them into a more defined use case so we can find it faster. So your model can locate. Think of it as a map. Big knowledge base, RAG makes a map, it's vector-based, of where that knowledge actually sits, so the model can recall that source of truth faster. All right. We'll go into more of those when we get going through here. So, real quickly, when we leave today, we'll show you how to get this running in a local way. I'm going to go through it literally step by step. You're going to watch the install. I'm going to configure each step along the way. You're going to see our files, where they're sitting, how we generated them, and you're going to see this math really, really quickly, how it's doing like you saw it before. And then if you have questions around how to go about doing that on your own device, if you want to try to follow along and do it, you're more than welcome to. We have 2 how-to guides. One's Mac, one's Windows. And when you download the files, you'll have access to both of those. There is a slight variance between each of those files.
And even if you're using Windows, depending on the Windows version, that guide may differ for you. So again, mileage may vary.
Okay, going back into kind of the stack here, the 4-layer stack. Key pieces, right? Web UI, we talked about being the gateway. This is really our chat.
Harness.
What?
That's the harness, right?
Nope, it's not.
It's not the harness. See, I'm still trying to grasp this harness thing. Still don't get it.
Web UI is our gateway. That's where
Okay.
we as humans are interfacing with it. With that harness is going to be our OLAMA. So
Oh.
Web UI, Open Web UI is going to be our gateway. Harness is going to be OLAMA. That is basically the piece that manages and serves the AI models and brings that data and makes it so it's human consumable for us through the gateway. The model we're going to use is going to be Qwen 3 14B. That's our reasoning, that's our brain. It's very specifically put in this demonstration as a small, lightweight model. It's still
Small,
fairly
9 gigs.
sizable at 9 gigs. There's a lot of smaller ones out there. Cam, you've used some very, very small ones. You have a couple examples of some small, like Gemma 2, Gemma 3. There's some really, really, really small ones that can run on very, very small pieces of hardware. So if you do have a laptop and you're like, hey, I want to use something a little more lightweight than this, do a quick Google search. Say, hey, what's a small model I could run in place of this if I don't have enough RAM? And they're all equally good, but they all have their own little variants of kind of what they do and how they respond. So it's kind of fun to kind of put new models in and see how they respond to the same data set. So this one, we're going to use Qwen. And our knowledge and tools are RAG. That's basically the source of truth. What this thing is going to do, where the calculations exist. As part of this, we also have created a Python script, and we've given you that as well. One of the prerequisite tools is doing some Python scripting. That's where that calculation is happening, right? So you have general knowledge we have, plus calculator with the model, through our harness to our gateway, is seeing the output that you guys saw. Okay? And it sounds nerdy, and it is. All right. All right, so basically the way that the lab's going to flow through for us, I will go through the baseline install of the core. You're going to see what would usually be downloads happening. I already have them all downloaded and installed, so it's going to blast through that really fast for us. It's going to install it through. We'll show you how we built the actual RAG files, the model files, and the different presets, how it's wired together, the prompt, how the agent itself understands what it is to do, how it's supposed to respond, what that's supposed to look like, how it's supposed to show you the actual work that it's supposed to show, and give you that actual outputs. And there's basically a couple files that are going to have all that in the QR link. We will give you all those files. That's the gold mine, folks. Those files are the pieces you want to see how they're formatted and how that knowledge is actually sitting in there.
I would have paid a lot of money to have those files about 3 months ago.
You did pay a lot of money. Now you
No,
have them.
so I would have been more ahead than where I am today.
And then we'll go through the tests, which we kind of already did, but we'll let you all throw some different tests at it in that prompting, just so you can kind of get a feel for it. At that time, we're going to have the Frontier model hooked up as well. And like just said, Frontier, big cloud versus my hefty M5.
I'm going to go through
MacBook Air.
some examples of why I don't put Pocket Justin locally. There's reasoning behind that we're going to show you, but I have a lot of other local agents that do other things that make sense. So when you're developing this, you're going to have to figure out what makes sense to leave on those Frontier models or in the cloud versus locally or on-prem. Does this still work? Okay, something happened in here.
I hear you.
Okay,
They're falling asleep.
I heard it click.
Okay, that's fine. Okay. All right, 3 files matter, right? The standards, the formulas, tables, logic, those are the source of truth, right? And when we made this file, Justin mentioned it being a 6,500 to
7,000 lines.
7,000.
7,000.
So we did a full test where I ran that entire 7,000 lines of code in this, and my old laptop just exploded.
Croaked.
No, it ran, but it took 3 or 4 minutes for it to even give us a response, because it's just too much information to overload that model with. It's going to take and just chew up all your RAM, and it's going to sit there, and you're going to wonder if it's doing anything. And then right when you're about to walk away, it's going to start spitting out text.
Or it'll blue screen you, one of the two.
Well, that's a Windows thing.
Yeah.
That's you. And so these are really the important files. The prompt being kind of the, I don't know how you respond, the rules of the road for the agent, how it's supposed to respond, what it does not do. As part of that, it gives you kind of the units. Here's our measurements. Here's how you're going to interpret the standards that are in that. Of that 7,000 lines, we parsed it into those 3 really, really small chunks for it, which is the display sizing, speaker coverage, and the actual conduit size, because we needed to get under a couple thousand lines of code. Okay. All right. So as we go through, if you're following along with the how-to guide, you will see it kind of broken down. It kind of gets into the install, which is really Homebrew, Olama, Python, Web UI. Those are the pieces that it kind of goes through first. Those are your big downloads, which is basically stitching it all together. This is not for the faint of heart. If you're not comfortable in command line, that's how all this is. And then pro tip, I suck at it, all of this.
I don't know anything about code. And the cheat factor of this is I used Claude, the Frontier model, to build my local agent because I don't understand code. If you understand code and command line stuff, you can do this on your own.
Yep.
If you're a programmer, probably able to do it without Claude.
If you have a Claude account or you're curious about Claude and you're not going to build it here with us today, pro tip, take the step-by-step guide if you're on Mac or Windows, drop it into Claude, and then ask it, show me how to do this step by step. Assume I know nothing.
And it'll walk you through it, and you'll have it done in a day.
And you'll be able to copy and paste every little thing out into the actual text console. And then if it hits an error, paste the error back into Claude.
A lot of people are like, oh, AI sucks because all it does is give me errors. No, you have to input stuff. You get an output. If that output has an error, you take that error, feed it back into your Frontier model and say, fix this. Gives you another output to fix your local agents. It might be hard to follow,
Yeah,
but we're not code experts is the sentiment there.
When we get into, you'll see me manipulate some of the settings how the model is going to operate. These chunks are really pieces of tokens or words. How big of a chunk do I want that model to see? How much overlap chunk to chunk do I actually want to see? And I only want to see X amount of these actual commands. So this is telling my model, I need you to be more efficient than you generically come out of the box. I want you to operate like this so you can be more snappy. If I didn't make these changes, this thing's going to try to do everything under the sun that is possible of doing, and it's going to take a real long time to get output. This is the microphone.
Eat it.
Okay. And we are on from, did you change me over? Yes. As we start, we'll kind of go from that baseline model, which will be from the Quinn, and we'll kind of set some additional parameters in there as well. You'll see where we're going to go through a lot of this, and then how it pertains to the local files we're going to have it in there. And from the previous question and Justin's inquiry around the difference between the gateway and the harness, the gateway that I'm using, Web UI, has a very specific setup that lets you see where we can make these changes. It's a lot easier. There are other ones out there that you can run. You can run, just do a Google search. You'll find different harnesses that exist for AI models. But this one gave us a real quick breakdown of where we can put our knowledge, how we can make the adjustments, and where we can actually tailor the outputs in one stop for us. Okay? All right, Chris, moving on from that one. Then we get into adding the knowledge itself. We'll show you the documents that we've created, where they sit in Open Web UI, so they're as part of our knowledge base. We'll upload where the tools are, which are the Python scripts and those tools that the agent will use. It'll literally open up the calculator and use it when it hears keywords. And then all that will kind of be put in one knowledge base repository that agent is set up to kind of use. Okay? Oh, no. And then finally, we'll go through a couple little pieces that show you where all that goes, some specific language, where we make those small adjustments on the formulas, and then kind of how we name it, how we recall it, how you can set it as a default agent, some of the under the hood wiring to actually make all the stuff work from the bottom all the way up. Right? And then when we're all said and done, we'll go through and do 3 validation prompts, which is basically similar to what we just did, and we'll test it and see who's still alive. Fair?
We'll ask you all for prompts, some AV, any AV math that you would ever want to know. We're just going to do it on the fly and test my 7,000 line markdown file.
7,000, okay. There will be some common failures if you're trying to do it. There's some little ahas, some checkboxes in the web UI. Common thing that may happen, you'll run it, you'll prompt it, and you're like, this is a really good answer, but it's weird. It doesn't seem like it's really following any of the stuff that I'm providing it. It's going to try to freelance and make up an answer based on what it kind of knows in its baseline capability, but you'll know it won't have your keywords. And so I'll show you to make sure you understand where some of those boxes need to be checked when it's responding, but it seems to be out of character. So we'll show you some of that as well. And then if you get no tools, if it refuses to do math, it's probably not connecting to the actual tools we made, which are those Python scripts in the back. If it's super, super slow, you may not have the correct model loaded, or you may not have any model loaded at all. It's just kind of sitting there waiting for something to happen in the background. Okay? All right, and kind of when we're all said and done, think of this as an opportunity to take what we've done here and think of the regular calculations you're regularly doing. You know, what are the pieces you're always having to calculate in your design files? What are the types of documents you have to create? It doesn't have to be calculations. You can have reference templates for bill of materials. You can have standard scope of work documents. It can pull all that from its basic knowledge base and recreate those things over and over and over for you, so you're not having to replicate that every single time. Right? So it can use those to do that stuff that you're doing all of the time over and over. Think of chunking these out as small little, think of them as web pages that are doing this work for you. 100% free on your own machine. Say free, you already own this stuff.
I have a local agent that all it does is I load it, a brief scope of work that I type out, I hit go. It's got a template of a proposal that I've put there, and it formats the scope of work, writes the bill of materials, the scope of work, and it's ready to go in 2 to 3 minutes for a client review, and we get POs from that. So to create that probably would have taken me maybe an hour review and typing it out and thinking it through or whatever, you know, the manual creation of that. So if you're doing a bunch of proposals a week, you're going from 5 minutes to an hour, you can see the efficiency there.
Right. So it's rethinking what are the things you're doing most often, providing the documents of doing those, and then launching them, letting those agents do that work for you over and over. Just as Justin said, his 17 sub-agents are just doing the work that he's regularly having to do anyway.
They're working and texting me right now,
Right.
honestly.
Blowing up. Okay, Chris, next one. Go, the one before this. This one, that's us. If you want to get a hold, if you want to yell at us, tell how terrible this was, go there. We each have our own little QR on there. There's our LinkedIn for that. And then that's just a web page, Chris, for the AV Super Friends, big one. We do a podcast where we shout about this kind of garbage, or Chris shouts at Justin and I to shut up and stop talking about this kind of garbage and AI and AV. Catch us for a couple times a month, or if we're live on Fridays, we do this. But we want to get into the lab, so we do it hands-on. Any questions before we jump in? Anybody not want to actually go and see the lab? You don't have to if you don't want to.
Chris does not want to stay.
You don't want to see
He
the
doesn't
lab?
want to see the lab.
Okay. If not, we're going to jump in. I'm going to go to the next slide, Chris, so people down. If you want to attempt to download this, go ahead. Or at least take a picture so you can download this to have these resources.
So there's a bunch of files in this link. The 7,000 line one, I think, is AV Master Design Reference or something like that.
Yeah.
And the others are for what Mark's about to build, which are chunked down and some Python stuff. Let us know if you can't access these files or you can't see them.
What's that, Chris? Does it work? Did you try it? Worked this morning? Okay. All right. So I'm going to terminate this
We can
session.
come back to this too if you need these later.
Is anybody going to attempt to try to do this? Does anybody have a Mac that they want to try to do this on? Nobody's daring enough to try? Okay. You're going to watch me copy and paste a bunch of stuff in the command line.
And if you feel like following along and you're brave enough, let's go. But again, it was a struggle to do this on my laptop, so.
So I'm going to show you all is how bad I am.
So don't forget
console.
that when you reinstall this, you have to go back and, yeah.
Yes. So I have open in front of me Claude. I have a basic pro account, nothing fancy, and command line on the side. Copy it. Swatting away at me. No. You can zoom in. Go for it. You're going to kill my whole work, though. Right there.
It's going to be hard to see.
It's all right. Does anybody have the files? Are they referencing? Did you get them, Brad? Did you put them on your phone? To Google Docs? No? Okay. What I'm running on this side is literally step-by-step in the how-to guide that you're going to have. I just have it in Claude sitting here because it's easier for me to copy and paste out of. I get the little copy button, and I'm super, super lazy. So I'm going to start at the beginning. As we kind of went over, at the very beginning, it's kind of doing the install of Homebrew, right? That was one of the slides you saw, installing Homebrew.
And what is Homebrew?
Homebrew is stitching all the different pieces, the Python script, all the parts together, so it's all going to work in your terminal area, okay? Think of it as the octopus is going to grab all that stuff and put it together for you. All right, and so I'll show you in real time. This is how lazy I become. It's going to go out and do it. It's going to ask for my password, and you guys can copy it if you'd like. But this is where we said it's going to take a couple minutes. If it wasn't on here, it's going to download all the pieces. Go out and reach the internet and say, hey, find this version, install it, go through. It's done, right? Once it's there, we're actually adding it and we're setting up some paths to my machine for HomeView, so it knows where all these, or Homebrew, so it knows where all these pieces are going to go. That's for this command that I just dropped in. You're basically building the pathways to all of these files that I'm putting in place. And then in the how-to guide, you'll see every one of these commands laid out step by step. You can paste in. A lot of it is always, hey, make sure your versions are correct. If you put it in Claude, it'll say, what version did it return? Copy it, paste it in. It'll say, you have the right version, or give you the next command to go download some different version if you don't have it, okay? As we move through, and you'll see that it's expecting here in the guides, it'll show you what it should have in the guide itself. Once Homebrew is installed, the next piece that it wants to go out and do is the Olama part, which is our harness. It's gone through. It already has it. It's already installed. It's returned and said, hey, I already see this. Olama's already there. It's already installed. We don't have to go out and do it. If it didn't have it, it would then say, would you like to go out and find it, install it? You hit yes. It's going to move through. All right. Once it's on and you've installed it, you open it. It's going to run. That's what Olama looks like. It has a bunch of different connectors that you can connect a lot of different AI stuff that you'd like to do. You can connect different agents and a lot going on. We just need it running in the background because it's the connector that Homebrew is using to actually move our models together. You can do a lot and have fun with Olama. Check it out. Play with it. It should be running when you're all said and done. We see it running a little cute llama upper right-hand corner, so we know that's actually working. We'll verify it. And when we verify, it's going to give us a list of all the agents and models that are installed on my machine. These are all the versions that are currently running. I've downloaded all of them. One of them you would see in there is the Quinn 314B, which here's some sizes Justin was telling you. If you can't see in the back, that Quinn model, 9.3 gigs, right? I had some other agents I put on here. I made some different markdown condensers. Here's a smaller Quinn, which is a 6 gig model. So if you have not as much hardware, you can start to run some of these smaller ones to actually fit on the machine you have. All right. This next step is where things deviate between Windows and Mac. On Mac Silicon, I'm running the actual MLX backend, which basically is provisioned for the processing and the RAM that I have on this Mac computer. Windows has a different workflow. If you look at that document, it walks you through those extra pieces of software. If you're running on Windows on the GPU or your CPU version, it's going to speak to that. Chris, you did try some of these, right? Right, you're good? You were able to get the Windows how-to operating?
Yeah, everything worked.
Okay.
A little bit hacking around, but it worked fine.
Okay.
And I updated the file that's in there is fixed.
Okay. So we'll run that, and it's going to basically fix the back end, so it's all back together. Installing Python, if you didn't have Python running, it would install. It's going to run through it. It's already there. Done, right? Python's not that big of a download. It takes a couple minutes to do. The big one that takes the longest is your model. Open UI comes next. Runs, it's already installed. OpenWebUI does take a couple minutes to download. It might be upwards of 10 minutes or something like that. I think the notes say it can take 2 to 5 minutes to do your OpenWebUI. It's not terrible long. We just didn't want to trust the Wi-Fi on here. And then we're going to effectively pull the models through. This is where it would actually download them all and make sure they're all available. And so it's pulled them all through. It knows they're all available to WebUI as set up. You would see them kind of crank through there. It takes a couple minutes for it to do it. And then I will load in the Olama. There it is. This would have been the download. It took 30 minutes. It would have gone through and pulled every one of these down for 9 gigs and all the pieces surrounding the model itself. So that one was the fast track for us to actually move forward. It's going to vary on internet speed, yes. And so, yeah, exactly. Have the fastest connection you can. Typical best rule I like to follow. I have 100 gig on campus, which is wonderful to download these things on. If you have access to that, use that. We'll verify. This is, again, a lot of verifying steps you'll see in there. When I wrote this, I told Claude, assume I suck at all of this. And that it is the first time I'm doing any of it. And so it wrote literally every single copy and paste command to do it, to drop it in here. All right. So that's our list. So once we have all of this stuff done, and you're back to your main prompt, which is this should be your device. You're all going to have different names of your device at the basic text command line. We're going to launch OpenWebUI, right? And I have it open this way because I want you all to understand the dynamic of what's going to happen and kind of where it goes. Here. OpenWebUI is a server. It's going to run in your command line. It's serving the web page in which you're interacting. So that is your gateway, right? So it's opening up here, doing its thing. Give me a second, let me go back to my cheat sheet. And as it's cranking on this side, you'll know it's up and running when you get the final little HTTP in a corner. And we, in a browser, we'll take our link. I'm in Brave. Paste it in. And there it is, right? Now, I already have a bunch of stuff populated. We're going to pretend that that's not there. I'm going to walk you through where the guide is going to go in each one of the web UI instances to actually go through and put the setups in. So right now you're seeing a web page that's being served. Back here, you can see everything that happens. Here, you can see where it's coming from on the actual back end of this. Okay. So once we have that kind of up and running, when you first launch Open Web UI, it's going to ask you to set up an account. Make a local account for yourself. It's not cloud connected, it's just on there. And ensure that you can log into it. It basically goes there. And then from there, we're going to go into the settings, which will be in here. As I stumble through, make this bigger. Okay. We're going to turn our embedded stuff on, and this is our chunking configurations. Documents. The wrong settings, sorry. Come on, where do I? I'm terrible about all this stuff, guys, sorry. Okay, and then settings, documents, okay. In here, as we set the chunking size, you'll see in there. So it's in the admin settings, our chunk size in this size. This is tweaked a little bit from the original 1,000 or 1,500 to do it, because I've just played with it a little bit. You can play with those if you'd like. When you change these, this is where you're going to start to see some time differences between how your model reacts. If you want it to be faster, change your chunk size down, change your overlap size down. Okay.
It just makes sense that it's faster to read a smaller file, right?
There's no trade-off?
Yeah.
There will be.
Yeah, because now you're going to need to create a bunch of little markdown files and a bunch of little databases and kind of segment everything out versus I use one master large file, but it resides in the cloud.
So we referred to RAG before, and it being vector, right? And so if you have 1,000 lines of script, each one of these chunks are literally chunks of that document, right? There's overlap between each one of those chunks. So some of the words in chunk 1 and some of the words in chunk 2. So sometimes you may get a cutoff. So if you had some formula in one of those chunks that spans into another chunk, you may not see the complete response. So if you're getting partial responses on an agent, you may have to expand your chunk size or reduce your overlap. Because if you had a very, very low overlap and you had a very definitive chunk size and there's no overlap, it'll say, I see this, but it'll give you like a partial sentence, right? Because it won't be able to pull from another chunk. It's basically using the vector to say, oh, this information is here. That's the source of truth. But if it doesn't have all of it from the chunk, it's not going to know to reference the other piece of material.
The strategy of this is to start small, and that's what I did. And the reason why I have a 7,000 line markdown file is because I've been working on it since February. Like, okay, let's build this more. Let's keep building. Let's keep building. So if you're running it locally, let's just start with one small markdown file, one equation. Let's run it. Let's see the result. Okay, well, that worked pretty well. Let's add some more information to that markdown file and see where it chokes. You're basically trying to find your ceiling of your hardware.
Yep. So in that kind of document that we had, it'll go through each one of these settings that you're seeing in here. It's going to have all these different sizes in it. It'll show you literally go in here, make this setting, make the adjustment. When all said and done, you're going to hit save, and then we're actually going to make the actual agent itself. Right? To do that, we will go over into our Web UI. In here, you'll see in our, we'll go back here in terminal, you can paste in an actual parameters for it, but I'm going to show you where it actually sits in WebUI itself. So if we didn't have an agent in here already, we would actually do, move that back to workspace. Here we go, UI. In here, if there was nothing in there, you would just have your plus, which would make your new agent. You hit plus, it makes your new agent called learning space assistant, and then in here is where you're actually going to add which model. So you're basically making the name. So the name of your agent in it, and then the actual model file itself. So I will go into the agent here, and this, and edit, right? So this is the actual meat and potatoes. So this is where we get into the system prompts itself. In here, what you're seeing at the top is in that how-to guide, it has the actual prompt. This is the information in which it knows. It knows your learning space AV design only, display sizing, audio coverage, and conduit fill. That's its identity. That's all you're ever going to do. Right? If a question falls outside of the scope, say no, suggest the user consult a broader reference. So this agent knows it's only going to do these things. Don't ask it to do other things. It has some rules. You're going to state all the values and assumptions, show the formulas, cite where it came from. That way you know the information you're seeing. It will actually tell you which document it actually came and pulled from. Right? You can see where we've added our speaker models, be specific about these models, flag, thresholds for borderline. In one of our prompts, you saw where it said, hey, you're on the edge of what the correct display size would be. It's going to give you some of that information. You can understand where that actually is going. So this, you'll see as copy and paste in your document that you can literally drop right in to build this exactly what you want it to be into that.
There's a lot of instructions with this. Here in a little bit, I'm actually going to show you my 17 agents working just to show you the capabilities of what local agents can do. Kind of like that end result and where I am real quick.
Right.
It's funny, it's in my home office on a Mac Mini. And I've hit the ceiling on my hardware with 17 agents.
You have like a recommendation on what you could base that in hardware or what
Start with a Mac Mini and go there if you have $600 laying around. If you want to start on your local laptop just with that one small equation and see what you can do with your local laptop, maybe start there. Don't start way up here, just gradually work your way up, if that makes sense.
You can run all this on a Raspberry Pi.
You can, but there's going to be a ceiling to all of this.
So going back to where we were on, I think the key really with everybody to see why I chose WebUI for you all within this workspace, the knowledge becomes really, really critical. And this tool allows us to manage where our knowledge sits much easier than some of the other gateways and / harnesses that exist on here. This one, it's quite simple. In our workspace, we can control which models we're using and our knowledge that we're using for each one. Within the documents, it's going to say, hey, make a new knowledge collection. I've made one that's called avdocs.ls, which is the learning space piece. In that collection itself is where our actual RAG document sits. This is where we upload any information we want that agent to have access to. Right? So this document right here, let's see if I can actually open it so you can see what it looks like. This one's very small. This is the entire document. Very small, being reasonable compared to the 6,000 line one that Justin has. This, if you can see it, has the examples. This has the formulas, right? This is where our basic sizes are. I've set this one to only use these basic sizes in these small conference rooms, small classrooms, to give us general rules of thumb to do it. You could expand that out as much as you wanted. You could collapse as much as you wanted, but I made these examples to keep this constrained so that it wasn't going to take a long, long time to respond, right? And so you can kind of see. Yep, exactly. So it can only see those 1,000, 1,200 characters kind of a thing in each one of those little chunks.
For example, in my 7,000 line markdown file, I've got BDM and ADM all mathed out with examples
Mathed
going
out.
from a 42-inch display all the way up to, I think, 159-inch. So if I query something, it's got those math examples already done, so it actually runs even faster. So instead of creating a markdown file with the math of a BDM and ADM, maybe just do your most common displays with the math, and then that result is faster.
So you can see in section 2, it's the audio coverage for living spaces. This is where we took the information from the BIAMP series and put that in there, so it's holding those documents in there. I created this by using Claude. I just gave it a links and say, hey, we're going to use these 2 speakers. Give me a markdown file that I can put into my RAG document for the relevant information that I need for each one of these speaker types. That's what it came out with, right?
Yes and no.
Yeah, it's plain English. It doesn't. There's no like command characters or anything like that. But there, you can see it's just basic spacing. There's no like syntax or anything in here. It just line just breaks in lines in there.
Simple text.
Yep.
Don't upload a Word document, things like that.
Yep. If there are sections that you notice, it does have kind of section breaks. You can kind of there's a section 2, 3, blah blah blah, all the way through. So it kind of chunks it down that way. And then kind of getting into the final section, which is your conduit fill. And these are all formulas that were pulled directly out of that 7,000 line markdown file, that text file that had those formulas in it. I won't give you the secret sauce how Justin built that. Let's just say it was tons and tons of documents from different groups.
Yeah. Might have put some things in there I shouldn't have, but
Yeah.
it worked out.
The lawyers will take care of that. For its worth, these are kind of where it's getting our source of truth of standard sizes of cable. If you had a type of cable you used all the time, you could put your actual spec and call out for your sizing of your cable in there, right? So it knows that I can only use these ones. What's up?
Question.
If you have those PDFs, documents with that knowledge in it, you would run them through the same sort of other.
That's a great question. I'm going to tell a mistake that I made. So I thought I was smart, and I was like, well, I'm just going to grab the actual PDF and load it in there as the markdown file. Don't do that, because what happens is it's got to create a PDF tool and scrape it, and then you're waiting, and then, oh, crap, there goes 10,000 tokens, and you haven't even got a result yet. Take those PDFs that you might get from certain standard organizations that we know and create a markdown file of just text from those, and it's more efficient than you would ever think. Does that answer your question?
Would you do that manually, or would you have another model do that for you?
I would cheat and use Claude to do that.
I have one running on a Raspberry Pi at home, Dave, that its whole job is to watch a Google folder that I have. Any document I dump into that, it takes it and turns it into a markdown file.
You can create
That's
that
all it
local
does.
agent to create markdown
Yeah.
files for you, not in Claude, but do it locally.
Yeah. And so
That's another way to bypass tokens.
going back to the basic questions, yes, you could. You could dump and put all those folders or files you have just in this knowledge base. The model's going to bog down. It's going to
choke.
try. It's going to say, let me go and read all this stuff, but it's going to just fill your RAM up. It's going to fill the model up. It's not going to give you a result. Unless you have like an RTX 6000 laying around, you can throw in there and just kind of chunk through some stuff.
I heard you say that, like, in certain cases, you just want to give it the answer. So it references the answer immediately, instead of really having to build the answer. Don't have to do the math. Here's the math.
It's faster if you have standards that you're like, I always use these displays. I heard like 95% of the time, these equations are going to work for what I need. And then if you come across, your 277-inch direct view LED wall that you need, you might have to add to that markdown file some more math.
But I'm saying you can put in something like, hey, here's a rule. If the room is between this depth and this depth,
Yep.
it's a 65 inch.
Right here. That's exactly what you have right here, right? So 15.9 feet, 65 inch, right? That's kind of how this is broken down. And these are just the common ones I put in. I say, hey, I don't want you to try to do everything under the sun. Then that's about to keep it lively. Like if you know most of your spaces are going to have displays that are going to be somewhere in this size, and you know what they're good at doing, build that out so that you know, right? So if you're in a room that's roughly this by this by this, it'll just give the measurements, hey, you're close to this. But it'll say, but based on the calculations, you really should be this size. But what you've told me here, this is where I would go through as a standard. If you want the absolute right answer, maybe it's slightly larger. It'll do both.
Some of you may say, well, why not just bring up the Avixa calculator and I just input the numbers real quick and hit calculate? That's that's pretty fast too. If you think about building out your entire workflow with this mindset, every little task that might take 5 minutes now becomes 1 minute. That all adds up really quick. Because I had that same thought, why am I doing this with that calculator? Maybe I should just skip BDM and ADM in my 7,000. No, it needs to be in there because now I go to one source for everything, no matter what my question is about AV design. Everything's so much faster now. So I'm designing 10 times as fast with more accuracy than ever before, which if you're an integrator, it's a lot of money. It's a lot of profit.
So within here, we could have multiple of these Markdown files. You could have one that's just displays, one that's just sound stuff, one that's just calculations. So your model will read anything that's in this knowledge base. So in the commands we told in its prompt, it knows I'm going to this document folder for my source of truth. Whatever I see in there is what I'm allowed to pull from to answer this question. Right? So in the how-to guide, the next step up is kind of the tools. There's a tools section in this. For this one, we did the AVSF calculator. In the document, it literally is going to give you a bunch of command code to paste into this. That is what you're seeing here. You'll see a big chunk of text that is the actual scripting. You're going to make a new tool, drop this in. This is Python script. It's just, so Web UI will run the Python script natively for you within there. Right? So it's running all of this script, which is basically doing the calculations, the actual math portion of what's going on. Right? So that's a tool. So you're building the tool for the model to actually run. It's in there. It's put in there. It's called the AVLS calculator. So that command script will build those calculators for you. It's in the document. Anything that's in this folder becomes available, again, as a skill / tool for the actual model to use. Do you have something, Justin?
Are we ready to show some things?
We're going to get ready to show some stuff here.
All right.
All right.
So this might be a little bit of a shock of all of my agents working, but we're actually going to see my business operating without me even doing anything here in a second.
Okay. So, but quickly though, I'm going to just go through and show them some of the pieces that the ahas to make sure where we're at. When you're looking at your model where I pulled down up here, select knowledge, right? We've got to make sure that this collection is there. When I said it seems like it's trying to answer, but it's not necessarily what I would expect. Oftentimes, this is not selected in your knowledge. Right here, you got to make sure that your AV docs is selected, and then that your tool is actually selected in the actual piece. And that's under the model. And so if you actually, I'll go back out. So I'll go here. In this model, where you're pulling down the dots, in edit, this is where all that piece is, right? These are the other things it can do. It can do all of this stuff too. So you can turn on and off these abilities that the model's capable of doing. So if you wanted to kind of say, I don't ever want you to do any web stuff, turn it off, right? It's knowing that all its calculations are supposed to be done by the local documents. That's in the prompt. But you can ask it a bunch of other things. It can go out and find the other tools. You can kind of suppress and play with those if you'd like to add more capability or reduce capability of your agent itself, all right? But those ahas, those things that weren't working, you're going to change those right here. Just make sure you have a knowledge base and you make sure you have your tools selected. Justin, you were saying, sir?
Let's see if this EDID works.
You want to plug this into that.
I'm going to try. Let's see what happens. If not, I'll just bring it up over there. I just already have it up right here.
Everybody. Do side by side? You're just going to show some agents.
Yeah.
Go for it.
So, can I sit this here?
No. Sit there.
Side by side. All right.
This whole thing's going to blow up.
Oh my God, it worked. Okay.
Microphone here.
So, what are we looking at? This is my office of agents that are running around, talking to each other, creating ideas. I approve the ideas that they come up with every Friday. Each one has a banner that is actual data that goes back to other things. Each agent has its own website. So Atlas is the orchestrator. It's my CEO. We've got like Mr. Research and Mrs. Money, and they handle all kinds of stuff. So Mrs. Security down here handles my network. We got 3 network switches running AV over IP. I got a QSys core. I've got all kinds of professional AV gear that it's monitoring. We've got Mr. Google and Mr. Notion. They run business. Mrs. Money handles all the money for the business. It shows live profits on my dashboard. Mrs. Social handles all the social media stuff. Let's see, Claude has Mr. Notion's in the game room right now playing. Mr. Google's working. We've got 24 new emails. Mr. Webby handles web pages. I've got crypto agents. I've got Mr. Support. Mr. Support is in charge of interfacing with clients that I spin off Mr. Support. I put it on a local instance at their site. They can bring up that chat through Olama and Quinn and all that stuff that Mark just went through and chat about their system and their problems. And I created standard operating procedure markdown files on troubleshooting first level problems. Our calls have drastically reduced because of this. So it's less work for me. So this is just an overall view of all my agents actually working. The ideas are down here. You can see them talking. Mr. Crypto says, all looking good on my end. And he's trading right now. All this stuff is live. If we go over here to the Atlas monitor, you guys may recognize this as a, I don't know, a dashboard, single pane of glass. I got an agent running this. I built this in a weekend. It's grabbing my AV over IP data, real telemetry data. It shows what's routed to what and the resolutions. This is live from Kentucky, all running locally in my home office. If you come down here to my amplifier, it shows that which speakers are muted and the levels, and my amplifier's been up for 924 days. We hardly ever lose power where I live, et cetera, et cetera. So this is my actual network and all the devices on my network constantly being monitored for security breaches. It monitors passwords, making sure I don't have admin and min in some of my stuff, which I do on my printer. So you might see like a red error down here with Mrs. Security. Port down, okay, WebSocket, okay, Telnet port open on that Netgear switch. Yeah, I left that open to test to see if it picked up the Telnet port to make sure it's open. So some of this is testing to make sure my agents are actually working correctly. I've got another page over here. That's the single pane of glass monitoring. It does everything that, you know, your room views and all that stuff do. This is an active log of every agent of what it's doing currently right now. Atlas is the CEO. It manages all the local 17 agents there. And I got a complete log of what each agent has done, any errors. Mrs. Social has an error because the X API is like $1,000 a month, and I was like, no, I'm not doing that. So I got to figure out if I want to tie Mrs. Social to LinkedIn or not, to be determined. Do you have a question?
I do. I feel like I'm missing something.
What's that?
How did you do this?
What'd you build it on, Justin?
Looking for here?
What did you build it on?
Yeah, what is this?
It's my AI team. What do you mean?
Yeah, but isn't there like an agent or something? Are you using some type of an API with a harness of some sort?
It's OpenClaw.
Is it what?
So it's just, all of this just runs on its own. There is no API, there is no, well, each agent might have different APIs. Like for instance, Mr. Google has the API for Google to check the calendar, the mail, and whatever else, the Google Drive, things like that.
Did you build it on OpenClaw?
Everything I built here that you're looking at is built with Claude code. And what that means is I created all my local agents using a Frontier platform to speed up my process. If I was to do this manually, it would have taken me years. But this is a result of work since February.
So when you say that, you're saying you got a Claude account. You went
Yep.
to Claude and said, hey, I want an agent that does such and such.
Yep.
So, and then you started, and then just worked through it.
Yep. And then you test. And so now, anytime that I develop a new agent, because I developed Mr. Merch to sell things, I don't know, just for fun. And then
Clever.
I have to do a smoke test is what it's called. And so I built in, anytime I create a new agent, it smoke tests that agent.
Mr. Smoke, yep.
Yeah,
Yeah,
Mr. Smoke.
well, I haven't. That's a good idea.
You can see where it's going, yeah.
So all of this starts with an idea. That's how you have to think of this differently. You don't worry so much about the coding part of that. There's tools out there that you can leverage that takes care of that for you. It's creating ideas, testing the ideas, making sure the workflow makes sense for your business or for your institution, and you can run all of this locally. Everything you see here is running on a Mac Mini for $600.
So, has anybody heard of OpenClaw? Have you heard the term? Okay. OpenClaw, open source download. It will give you the easy on-ramp to build what Justin had done. I think he dabbled in OpenClaw to start this, and then through trial and error got to the point where you can run Claude Code. Claude Code, you can just have it run in the background. Hey, Claude, make me this. Start putting it together. If you don't want to go that route, OpenClaw will give you kind of an on-ramping. You install it at terminal, install, goes through, and it interviews you. And you start to build. You build a personality type for it. And that's, a lot of folks got into agents by way of OpenClaw over the last 9 months because it allows you the easy on-ramp to start to build out what Justin is seeing. Once you go through it, yeah, go ahead.
Did you say OpenClaw?
OpenClaw, like claw, yeah. And so there's a bunch of derivatives of it out there. Hermes is one of the derivatives now. They're all very similar, where they're allowing you to build these small micro agents, orchestrate a group of them at the end of the day. And what Justin's showing you is that orchestration layer, all of those different agents. OpenClaw will allow you to build those really fast. It is a framework that puts in there. You can put your OpenAI account in there so you can have a brain running a model. You can also have it run a local model for you. So it'll allow you to start to do some of these pieces. Word of beware on this, if you put that on your work machine, your network security guy is going to be pissed really fast. Do that on your home stuff, not your open network at work, right? Because you can allow it to have access to things you probably don't want it to have access to. If you put your credentials in there for the things you can do, you're giving it the autonomy on your behalf to go out on all the file structure that you have access to and wherever you can go on the network. So security folks hate it. I'll tell you that right now. There are secured ways of running it. There's
Not
NemoClaw
all.
and things like that. Not all of them. But if you're really curious and you want to play with these things, that's a good endeavor to kind of walk through. It can be fairly complicated when you get into it. It is an easy setup. It's really fast. And you'll understand where it's going. A lot of what I went through in here today, you'll see in the DNA of OpenClaw as well. Those agents, the knowledge base, your model, stitching that all together. It's kind of a quick start guide to do that. If you get it going, you're going to have like a week's worth of nights that you're going to be up all night just playing with that.
I lost a lot of sleep
Yeah.
on this, to be honest. So this whole thing started with the dashboard. We all want this single pane of glass, and it's super expensive if you buy it from a manufacturer, and people are trying to develop, their own instance of this. Well, I did it in a weekend, and I was like, well, let me keep tweaking, tweak some more, and now we're at an enterprise level to where I'm spinning off agents from this whole cluster of agents I have, and I'll throw it on a virtual machine at, let's say, the Bowling Green Fire Department in town, where we built some AV systems, and the police department. And there's only 2 agents running there, Mr. Support and Atlas. Atlas handles the dashboard. So the IT team can log into the dashboard, monitor all the equipment just like anybody would want to, get real data from it. And then the chat instance, Mr. Support, is there for the client side. Hey, my microphone's not working. What do I do next? What should I do? And it goes through a decision tree of, true statements. Does the other mic work? Does this work? Okay, those things don't work, then try this, do this. They can have their event without calling us. That agent reports back what happened to us, and we go on site later to find out what actually happened. So these are real tools that save us time and money.
So I think shorthand, what we went through today being your gateway, your harness, your model, and your knowledge are going to be your critical pillars when you start talking about agents moving forward, okay? Even if you do OpenClaw, you're going to see that there. It's the same thing that's running in the frontier. The same theory exists there. They're doing the same thing for you. They're just serving it on their machines. With that concept, you can kind of build out. We want to show you some side-by-side so you can see what this one's doing and what response we get from Pocket Justin, so we can kind of go through that so you can understand some of the
So are we
differences.
going to do pocket, we're going to do
Sure.
the comparison now?
We're doing
Okay.
comparisons.
So this side can only see this TV and vice versa. What we're going to do is I'm going to pull up my laptop with my 7,000 line markdown file running in Claude, and we're going to ask it some questions that are very similar, exact
questions.
to the local model. So let me switch the HDMI over here.
Anything from the back of the room, Chris? Good. What would you all want to ask this thing? Bear in mind.
Is it a wild card?
Well, within the three contexts that we have, let's compare them that way. We can do the same examples again if you'd like to do the same examples again.
Let's do a screen size calculation and figure out, how big these screens should really be. Yeah.
Okay.
I agree.
What was it, 34 deep? It's 24?
Did the text it? This was working when we tested it, of course.
It's a page-based model, just believe me.
What if I just renegotiate? Look at that. All right,
So I'm going with how large of a display do I need for a room that is 24 feet deep?
So this is the 7,000 line markdown file that I pulled up. It's got subnetting calculations and anything that you could ever think of. Let's go.
So if you want to take that
Over
and
here.
build different agent models, drop that into Claude or just OpenAI and just say, hey, use this document and create a markdown that I can use to make a small agent that's just doing subnet or whatever it is. Just make a small local one and just use that as your source of truth, and it'll pull it out and format it correctly for you.
And it's better to have this collection of agents as opposed to super agents.
So basically, that's what Justin's doing right now, like having one big one sitting in the model or in the cloud in the frontier that's basically moving all of that document up and down all the time, which is costing tokens, right?
Okay. But if you have a bunch of agents, then you need the orchestrating agent. Otherwise, you spend a lot of time switching.
If you're going to go between different ones, if you want to have that full orchestration layer, yes, you can have that. But if you're just doing simple calculations, maybe you don't need to be live all the time. You just want to turn it on when you need it, turn it off when you don't need it. But yeah, if you have a lot of continual calculations, you're always monitoring, you build dashboards and the like, then yes, you want to have all those little sub-agents and then an orchestration layer on top of that.
For example, I labeled Atlas the CEO of all the agents. So I only communicate with Atlas. So I get text from Atlas and I text back to Atlas what I need to do and what needs to happen. I've got a Mr. Acoustics that I have to do with Telegram because it needs pictures of the room to calculate RT60 for me. That's a super cool agent. I love that agent. But I'm going to show, so this is Claude. So I've got the markdown file loaded into files. It only used 5% of that project. This is a project, and I got a team because I got other people using this. The instructions are set here. You're an AV design assistant. You do this, things like that. And then we're going to start a new chat in the project. So what do we want to ask it, Mark?
How large of a display do I need for a room that is 24 feet deep?
How large of a display do I need for a room that is what?
24 feet deep.
And that's the only prompt that you're going to give
That's
it?
all I'm going to give it.
So I've set mine to ask me questions if I don't give it enough details. So let's see what happens. Go. So it's reading the 7,000 line, and it's already pulling.
My little MacBook is just, I think I can, I think I can, I think I can.
So what do you want me to run this as, ADM or BDM, or what's going on here? So run as BDM.
And so mine's not generating an output.
3% element height, thank you.
So based on Justin's documentation that I've stolen from him, display sizing. It is recommending,
108? I got 108 inch.
mine went from my standard, it says 110. Based on my standard ones that I put in there, 110 is what it's telling me.
So I've got an actual value, like to the inch, and then I either go up or down with my brain decision on if I want to increase that display size or back it off to a 98.
This agent did the same thing, 53.7, right? And so, but it just said, okay, that's our height, should be that. But based on your standards, the closest thing you have in your fleet is going to be that 110, right?
Does anybody have a crazy AV design question?
If you're crazy, ask that one. If you have some-
Let's ask,
Yeah.
because I want to, if anybody got an off the wall, I'm just trying to use you all to test my agents.
In esports arena.
Nah, it's not.
Like, what?
I haven't built that agent yet.
Esports, that's a Larry agent. Brad, what do you want?
Can it do pricing?
So, great point. So this is why let me go through why I use this in the cloud and not locally. When I use this in the real world, I'll say, how big of a display do I need? And also give me the options for this display, choose these manufacturers, and give me the model numbers, and give me the price that you find on B&H Photo for budgeting. Having that in the cloud allows me to do additional research beyond just the math, which speeds up my process. Every output is verified by me. That's also very important. It will hallucinate on you and make stuff up from time to time. So you don't copy and paste and then send the email. Copy, paste, review, then send email. We're working on an RFP, redoing that, and I had to come up with an Appendix A of scope of work for the integrators to price out, and it was just a fake. I went through 6 versions of that 2-page scope of work to get it right. But again, I didn't have to think through how I wanted to type it and the language of it. That's just more of that efficiency level. And that's what most people use AI for, is that efficiency level. What you're seeing Mark and I do is the creation level of AI, which is that next step.
Yeah. So if you had standard pricing, if you had a partnership or whatever, you're always using these displays. If it were me, if I was setting up my local, I would put that stuff right here. Right? These are my rough prices that I have for 65s, 110s, things like that. If it's there on that file, it'll give it. You can say what size display and what's my rough cost for it.
You might go ahead. You might have a agent that does your classroom level 1, and you have a bill of materials there with pricing, and then classroom level 2 agent, 3, and then a wild card. And if you run, a simple command, it could spit you out a bill of material, a price, possibly labor estimates if you need that in higher ed. Some do, some don't. It's just whatever you want to see the output put in that markdown file.
You got a follow up on it?
Oh, I was thinking in terms of trying to come up with this prompt for you. I was trying to come up with something along the lines of like, I have an auditorium that's 80 feet deep. When is a DB LED wall a better design decision than a projector and screen?
How many zeros do you have in your wallet?
Sorry, I'm a consultant.
yeah, exactly.
But I'm trying to think of something crazy, because there's so much open-ended in that.
There is, yeah.
Right? Resolution isn't in the prompt.
So Mark, while he's doing that,
Mhm.
is there,
Okay.
Yeah.
is there a way for your local model to also do web research?
Yes. It can if you ask it. So if I were to get a result and say, hey, go out on the web and find me an example, because in the actual tool itself, in the model, we've allowed web search, but its first response is to only pull from what I've given it. If you're like, well, if I don't have that, and we can try it, I don't have that model, can you go out to the web and find me an example of what would be comparable in that right size? It'll do that work for you.
So my prompt right now, and we'll test this. I don't know what it'll give. I don't know what it'll give me. I've never done this prompt before. I have an auditorium that is 80 feet deep, right? Use the design file to compare a projector versus direct VLED solution for this space and give me guidance the best you can. Let's see what happens.
Fired up.
This is part of the testing. And then if it doesn't give me what I want, I go back to that markdown file and find, okay, why did it give me the response that it did? Because I didn't like that response, or it's wrong. So I got to go back and figure out what to do. It says, good, I got everything. Here's all the assumptions, discus. That's a massive image, yeah. Projection, option 1. It's going through all the math for me. Oh, it's doing ISCR. That's important, right?
80,000 lumen projector.
There you go. It's 15 to 1. Is that what we're after?
I'm doing it right now.
Option 2, direct VLED. And then, so if it didn't give me a cost analysis.
Right, you just asked for the best guidance that you give.
Yeah.
Again, open-ended, which is fine, it's part of the game of playing.
Gives me pros and cons for each solution. Engineering recommendation. Oh, look, there's some costs. Structural. Then it asks me a question. What do you want to do next? Now, how long would that have taken you all to figure out? Because it took me 30 seconds. Who's your competition? It's my belief that AI doesn't replace people, AI enables people. So you have all these people getting fired and all that stuff, and that pendulum is way over here because AI is cheap. Remember what Mark said about AI getting more expensive? These corporations are going to go, oh no, that pendulum's going to come back, and now CEOs are going to have to figure out, do I use AI to do this task, or do I need people to do this task because of cost?
The things that are just repeatable, push the button, do these things, and it's the known thing over and over and over, those are easy efficiency AI things. Talk about AI as opportunity AI. What can we become better at? How are we better partners with AI? How are we being more efficient? How are we actually driving value?
Question.
How many tokens did you use?
I don't know, because that's a good question. How many tokens?
You ask it.
I'm not sure. Well, let's ask it.
It'll give you a response. Spend some more tokens.
I'm actually under utilization this week because I haven't been at home at night pounding away at this thing.
So for this one, since I've constrained it and the model, it's not going to go out in web search. So we did a quick test. It's only going to base its answer on the actual knowledge that's relevant. But it'll give you some prompts. I asked it if it can go out. It said, hey, go out and look for these things. Look for some commercial grade displays. Do this. And said, hey, drop it into search and see what you can come up with.
So I asked it, how many tokens was that, and estimate the cost of tokens used on that request. It's not.
And convert that to Northwest Met bucks.
I don't have a token calculator. Input 25 to 30,000 tokens, output 25 to 3,000 tokens. That was roughly 21 cents that I just spent to do that direct view LED versus. Now, how much labor would that have taken me on an hourly rate versus 21 cents?
Right.
That's the question.
All right.
Yep, Chris?
Chris?
You guys have been demoing this stuff in Claude. What if I have a general photo account, Coppola garbage account?
Coppola garbage.
OpenAI, I'm sorry, I'm Coppola.
Yes.
OpenAI, if I'm using a different cloud service for this, can I do the same thing in that?
Yes.
When you built in Claude, that seems to be at the time the most capable system for this, but are there other ones just as capable, and what are you going to be using in 6 months that doesn't yet exist because you guys weren't?
Yes. So
I'll let Mark answer first, and I'll have probably a different answer than Mark. So.
maybe. I think the short answer, Chris, is yes, you can use a lot of different versions of this. I've done similar work in OpenAI, which is ChatGPT. Treat it the same way. Copy, paste, throw things in there, do a general kind of conversation with it. It can get you the same output. They are different in the way that they've kind of postured themselves, and you understand language. If it was my preference, I like Claude because I've asked it to be a very specific way. I found that working with OpenAI, it likes to just dump a lot of stuff on me, and I have to parse through it. Where Claude is much more like, specific to the single task that I asked it, or OpenAI is like, here's everything you asked for, what would you like me to do? And I was like, finish it, I guess. So
Part of this is also how you train your frontier model. I've spent a lot of time training Claude on how I want it to act. If you train ChatGPT appropriately, you can probably get it to do what Claude does. What I've found is that for a business and for serious work, most of the time I would try to use Claude. But Claude will tell you, if you're generating images, use ChatGPT, my competitor. It literally told me that. And so I have ChatGPT as well, ChatGPT as well, to help me develop, like for instance, when I do sound panels for a client, I now have the ability to walk into a room, take a picture of the wall, dump that into ChatGPT, and I've got an agent there that designs the sound panels how I want, spits out an image. Man, it's really good. Put it in front of that client, and they're like, I don't like this, this, and this, change this. Yeah, no problem. 5 minutes. How's that look? Let's go with that. I'm out of there. That's like a 20-minute conversation, and the client knows exactly what that's going to look like before we even do any work. Copilot, if you're in higher ed, Mark has a opened up, throttled Copilot instance. Mine's like baby, cutting teeth, stupid, like it's really bad. And so Mark showed me something that I could do in Copilot because it's the free version where you create, it's basically faking it out to create an agent to where you give it a prompt and then you have to schedule that prompt daily. And what it does is it emails me my task list based upon my email and calendar for that day. And then there's another prompt that gives me a summary of some stuff. It's useful, but I've already hit the ceiling with my Copilot instance. So if you hear somebody talk about, oh, Copilot's great and you can do all this stuff with it, and you're like, man, it sucks. Where like there's some licensing difference and there's some institutional differences there based upon that. So anything to add to
no,
that?
I think for the most part, they're all good at the things they do. They're all not good at everything equally. Copilot can be good for your instance of your Microsoft environment, right? Just because your organization has what that's licensed for, and if you want to be efficient in that environment, use that. It's secure that way. Don't throw your Microsoft stuff into Claude and try to get a bunch of answers because it give away all your identity stuff. What I'm going to do for you all is what I promised I was going to say. I'm going to take the how-to guide, and I'm going to put it in Claude the same way I would recommend all of you guys to do to start. Just say, I don't know anything. Take this how-to guide and show me how to do it step-by-step. Right? And so these files I have right here are literally the exact guide. I'm just going to drag them and drop them in to the actual file. If I can get them to actually go in here. I'm going to drop it in. I'm going to ask it, help me build, I suck at typing, don't take it personal, an agent using this guide. Give me a copy and paste step by step.
Let's say I'm lazy.
I am lazy.
I want to go through and do this step-by-step stuff. I feel like this AI should be able to do this for me.
That's where I was going to have Justin do a one-shot in Claude Code for
Cost
you.
you money.
Okay, all right.
You want to do it, Justin? You want to one-shot it?
What are we doing?
Take the how-to guide, throw it in Claude Code and one-shot it. Have it build it for you, right? One-shot.
Right now?
Burn those tokens, brother.
Right now?
Right now.
Show me what you've done. Maybe pull up in Codex. All code can't do it, but
This markdown file?
No, the how-to guide in Google Drive.
Okay. Let's see. No, wrong.
And see, it's already asking me because it's Reddit. It's like, do I have these things installed or not? It's going to walk me through piece by piece. I'll tell it I have them.
Where is that markdown file?
It's in the notes, Justin. So this is how I work with Claude. just right here, like right here, bang. It's going to ask me, do you have these files? Yes, I do. And you can see, it's just going to say, hey, first thing, go to terminal, do this, paste it in. Literally just follow the piece as it goes. If I run, I'll go to terminal and I'll make a mistake and I'm going to show you how I get past a mistake.
AV Learning Space Agent Guide for Windows?
Yep, well, that's for Windows. Go ahead and run that one. And so as I go through, I'll do this, and nothing happened. I say, okay, Claude, what happened? Did you do something? Did you not do something?
So we're building an agent?
I'll copy and paste it right back in, like that. And it'll give me a response that, hey, you did this. Right? So it says, hey, that worked. Now do this.
So we're just building an agent?
Yep, based on that document. Just have it one shot right now.
So you want to go into Claude Code?
Yep, yeah, do it in Claude Code though. So for those who have not worked with Claude in that way, this was just to show you that's if you want to have a start to jump in to do it, just take that document that we shared with you, drop it in there and say, help me build this. And it'll just go step by step. That way you don't have to actually copy and paste out of that document, and it'll give you reference. And then it knows if you run into an error, it'll stop, help you fix the error, and then pick it right back up where it was. Cool? Are we actually at time at this point?
I've got problems with Claude Code on this PC.
Oh, well. How long is our actual session for, Chris?
But it's built it in Claude.
Are we over? Yeah. Well, I think at that point, we've shown you everything we had that we were going to share. No more slides. And this is just kind of Q&A. Other questions around this at this point? It looks super complicated, dangerous. It's not all that bad.
Here we go.
Jump in and go for it. That's the best stop. Just take what you have, the references, dump it in there, and just start going for it.
So, it's still building.
Did you have the file?
Could you take that same prompt and just throw it into Claude Code? I'd be interested to see if Claude Code could just figure it out.
Probably. That's just not what my workflow I'm used to.
Where are you running it from? Are you going to drive it from there? You're going to do Claude to Claude Code? Okay. Chris, do you have any questions?
You can actually see it building the document right here.
Did you give it that document?
Yeah, I loaded it in. It was the markdown file.
So it just took the how-to guide and it just dropped it in there.
The main thing,
that I learned through this whole process is it seems very tedious to do this stuff. If you have the patience to see it through, it just makes your life, your work life, completely different. It's changed my stress levels. It's changed how I work. I can send designs and documents faster than my PMs can read them now. And so you want to get to that, zero inbox level, this might be a way to do it.
All right. Well, I think we're going to sit here and watch Justin try to one-shot an agent with Claude Code.
Yeah.
Any other questions? No, if not.
If you want
Yeah.
us to help you set some things up on your laptops, for those of you who have them, we can help you with that. We have extra time today. We're at your beck and call.
All right. Well, thank you all for kind of coming through and stumbling through with us.
this is a big agent. But Claude might be inflated.
It's getting there.
Oh, look.